Hey, what's up guys? This is Akshay from AS Learning and today we'll be seeing how to do diabetics classification using deep learning. So the problem statement in a hand is that we have a data set and we will be training a neural network to tell whether the typical person is diabetic or not. So we have around here 8 features: pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetics, pedigree function, and age. And we have a target variable, that is outcome, whether it is diabetic or not. Okay, so this is my data set, and we'll be solving this problem by using ANN, that is artificial neural network. So let's get started with the code. So the first thing I've done is imported pandas. I'm reading my CSV file, that is diabetes.csv. Present working directory is home intel 123. To yeah, cool. Now what we'll be doing is we'll be as we know, if you see the data set, it's entirely numeric, so we don't need to convert any categorical into numeric features. And also you see the ranges. Also the ranges are cool, but if we apply standard scalar, it would be better. So yeah, what we'll at first do is we can do this separately also, and before splitting into x and y. So what here I've done is that I have first splitted my data set into dependent and independent variables, and I've uh, done the train and test split classification, and after that I've performed standard scalar. Well, it's always better to do this standard scalar and all the other pre-processing activities before this split and this assigning of x and y. Okay, so here I've allocated my x and y variables, and then I have splitted my data into x test and y test, that is training and testing data. I have kept the test size as 20% and my training size is 80%, and I've kept the random state to okay. After that, I've applied standard scalar, so I am normalizing all the values between 0 and 1, and I'm fitting it on xtrain as well as on xtest. Okay, now we'll start with the neural network building. Okay, so here for building an ANN, I've used Keras, and so first I've imported Keras. After that, I've imported sequential, dense, and dropout. So first I have created an classifier object of the sequential class, and with the function of add, I am adding my different layers. So so we know that the number of features into my data set is 8. As you can see, 1, 2, 3, 4, 5, 6, 7, and 8. So that's why my input dimension here will be 8. Okay, I have kept the number of nodes in my first hidden layer as 16, and I've selected the activation function as ReLU. So ReLU stands for a rectilinear unit, and its activation function. So if you want to see activation graph of ReLU, yeah, so ReLU looks something like this. So what it will do is So whenever the values are greater than 0, it will keep the values as it is, and whenever the values are less than 0, it would curtail it down to 0. So all the negative values will be brought down to 0, and all the positive values will be saved out. Okay, so this was my structure of the first hidden layer. After that, I've added a dropout of 0.2 just to have a check on the regularization. So by default, neural networks are tend to overfit, and dropout is one of the way in which it is one of the regularization technique for controlling overfitting. So in dropout, you can keep a parameter from 0 to 1 on the amount of regularization you want to control. So I've kept it as a 0.2. Now in my second hidden layer, I won't be needing my input dimensions. So all I have is my a number of nodes and my activation function. And last but not the least, because it is a binary classification problem, whether my patient is diabetic or not. So my final dense layer would include only one node, and I've kept my activation function as sigmoid because it's a binary classification problem. Okay, so let's create the architecture. Here it is saying no module name Keras. Okay, so I think I'll have to do is I'll have to activate the virtual environment. Okay, what I've done is for uh, to not have dependency issues, and all, I have created a separate virtual environment for all the deep learning activities in which I'll be using Keras, and the name of that virtual environment I've kept it as Keras only. So I'll change the working directory also, but and run the code up till create structure of a neural network. Okay, cool. Now let's compile a neural network. I've kept the metric as accuracy. My optimizer is Adam. Uh, it is a renowned optimizer, and I've kept my loss function as binary cross entropy because it is a binary classification problem. And now I'll be starting with the uh, training of my model. So I've kept the epoch as 300. My batch size is 100, and here I'm fitting my X train and Y train. So I'll explain you what epoch is. So in one epoch, uh, I'll be showing my entire data set to my neural network, and and I've kept your batch size as 100. So these entire data set would be shown to my neural network in a set of 100. Okay, so that is the difference between epoch and batch size. Okay, so let's start with the fitting. Because the number of data set is very less, it's I think only 800 rows. So it's done, and we have achieved the accuracy of 78%. So not bad. Okay, I have just predicting out on my X test, and we'll see how the confusion matrix result are. Now if you see here, it has classified around 94 plus 29 entries properly in my test set. So if we check the accuracy of it, it would be 94 plus 29 upon this entire thing. Yeah, so let's check it once. So it was 94 plus working. Okay, plus 29, that is 123. Okay, plus we have to do is 13 plus 18 more, that is 13 plus 18. So my final accuracy would be 123 divided by 154. Sorry, 123 divided by 154. 123 divided by, I have taken the percent of 123 divided by 154. Yeah, so 79.87 is the accuracy I have achieved on my test data set. So pretty much good. More enhancements here can be done by applying grid search and random search on different parameters of this ANN. You can play with the batch size, the epochs, the dropout ratio, or you can also use Keras tuner for coming up with the optimum values of the number of nodes and number of layers. Okay. So that's it. So that's it with this video, guys. If you like this video, give it a thumbs up, share it with all your Python and machine learning enthusiast friends, and stay tuned to AS Learning for more such amazing tech stuff. Thank you. Take care. Peace out.